Okay, everybody, so we're going to return to coding here. Now, the objective of this coding session is to pretty much polish up the JSON processor, get it to function much more elegantly, more efficiently, much better usability, especially since we've now proven that the system does work. We can load files. They do load in live environment. I don't know if I did another video on this, but I did get everything working. Our build server should be back online now. So we're going to start releasing sometime this week or next week more builds. This will include the armory mod. The armory mod will actually start to get content because now that we know that things are working, we can start to develop the content. Our existing mods, and by the way, apologies for sounding out of breath. I just got out of the shower here. So our existing mods are going to get ported over to JSON. This means as much content as possible. Anything that is not tied down to some kind of a highly complicated logic system will become JSON. The whole reason of this is I've had mentioned in every single video is to drop down the amount of code required to make a mod functional, to get it as low as possible. That way, every time we update for a new Minecraft version, we don't have to do a lot of work. This also will come into play here later when I go to produce a Minecraft-esque like game. All the JSON content will be able to be ported over to that game. That's multiple years down the road, though. I don't plan to make a Minecraft-like game for at least 3 years. But as you can tell, I've got some code up here, so let me explain what I've got right now. So I built a debug printer. I put a tweet out here about an hour-ish ago or two showing the output of this. So the output is much cleaner. We were just printing out stuff, and any formatting we had was being done in the method, and it was being handled kind of sloppy like. So you had some things that looked nice, some things that didn't look nice. With the debug system, we can ensure an indentation is guaranteed. We can ensure that everything flows well. This is handled via this system. What we do is we can nest and unnest sections. So every time you nest, you indent. Every time you unnest, you unindent. So it's the same thing like hitting the tab key on your keyboard when writing a Word document, you indent. The only difference is this is kind of handled procedurally, and we can do it by simply starting a section, and we can do it by ending a section. Now, what I'm working on is kind of to make this work even better as I keep iterating over the design as I've been working. So I made this morning. I envisioned this the last couple days. Like, I understood that I needed to create something like this because I've done it in the past. One of the explosive systems has a debugger like this. In order for me to see exactly what the explosive is doing, to tell me how long it's going to take to complete each action so I can start to optimize down the code. That's how I got some of the explosives to run as quickly as possible, as I could visually see what was happening. This class is going to do the same thing. There's going to be a upgraded version of it that is going to have tracking on it to track and profile how long methods are running. So not only can we start an into section, we can actually track how long it took for that section to start, how long it took to end, how long each thing inside of it ran for, and stuff like that. Right now I'm making another version of this real quick that I can turn the logger on and off procedurally, and this will come into play when I want to do debug code. So you notice there's tons and tons of information here. This is not going to be useful for most users. So this is going to turn off in the default workspace. So if you ever, or the default version. So if you ever go to load VoltEngine up and you're expecting to see this information, it won't be there. It'll have to be turned on. But I can procedurally do that, so I don't have to go, okay, are we enabled, are we not enabled? The debugger will run no matter what. Unfortunately, this will mean a slight increase in overhead on all the methods, but we're talking slight as in nanoseconds. So literally less time than it takes you to blink is being added to the overall process. So for this, what I am doing is I'm going to change the enabled status. Trying to think of how to exactly do this and handle this properly. One, I do need to actually define the section heads real quick. I forgot to do that. So we can declare names of sections as well in here. This is actually going to be, the first thing it's going to be used in is the block processor. The block processor is being transitioned over to improve code. As you noticed from last time, we had a huge section, I believe right under here, that was loading up all the data. That's gone. That has been replaced by the JSON injection map, which is a reflection-based utility. I have not fully coded yet. I have coded field loading, but I need to do method loading, and then I need to do actual injection handling. This will replace the need to declare new fields every time we create them. So we won't have to touch this class every time we add data. What we do instead is we go in here and we declare this real quickly, and we can define as many name keys as we want for this. So if we want to have resistance, block resistance, resistance something, we want to have like subtype keys, we can implement multiple key types here to improve our handling of JSON. Now, for those who are familiar with JSON handling, the reason I'm not using pre-existing libraries for this is I actually want more control. JSON and other libraries have support for something like this already, but from what I could tell from my lack of experience, of course, because there probably is a way to do this, it would only process this stuff. And if it ever hit something it couldn't understand, then it would freak out. Now, I could use Lambok and a couple other things to improve this, but I don't like using Lambok because it sometimes works, sometimes doesn't work, and this is, of course, back to the idea that I don't have a lot of experience with it. If I had a lot more experience, you would see me using that tremendously. Like, I would be using it for getters, because look at all these getters we have down here and all these setters. It makes the class look ugly. Back to here, so we got to implement this here later. We have to do methods, so methods aren't even implemented. Fields are implemented. This should run. Of course, this will crash if it fails, by the way. And then where were we at? We were in the debug printer, and we were going to do the section header. And then we got to do the boolean here. So we're going to have to add some kind of previous system here. Procedural logic. What procedural basically means is that you're doing something. Actually, hold on, let me look at the definition, because as my buddy Shadow points out, I am horrible with definitions. They don't have procedural definition programming. Okay, it does mean what I mean. It means there's a procedure or process that runs that defines how this works. So in this case, it's going to be engine is in dev mode is what we're going to use. We'll use a secondary variable here later. So we'll have engine dev mode, and then we'll have enable JSON logging is what we'll have. So we'll have two variables, and we'll come up with some ways so you can differentiate between them. Because right now everything depends off that running as dev to do logging if it's not meant to be seen by the user. But we kind of want to be able to turn on the JSON logging independently from the dev thing, but at the same time we want to not have it run outside it. There's a methodology we would have to implement. There would have to be some kind of variable system, and we're not going to worry about that right now because what we're going to do is only do run as dev mode at the moment, because that gives me the logging, but then you as the user does not have to deal with it. Okay. And let me decapitalize that because that's not supposed to be decapitalized. So when we go to enable or disable a section, we need to make sure we store the previous, and then in the end we need to restore the previous. So enabled equals previous. And then if you call this, then this means previous enable needs to be true, and then previous enable needs to be false. So calling enable and disable is actually a global set and unset. So we'll make sure we note this, so that way if somebody's utilizing my class as the documentation will reflect exactly what it's doing, so they don't have to come through and read all this. So end resets previous, and then we want to do is in previous enabled, we want to make sure we get the enabled status. We need to do this dot enabled, and then we want to go this dot enabled Speaking of which, somebody told me I could do this. Oh, yeah, it does work. So you can hit tab to do things rather than hitting enter. So that actually does perform better. I'm just going to have to train my brain to hit the tab key rather than the enter key. Going to be hard. This is the same reason I don't use things like Visual Studios, because Visual Studios, I believe, uses tab. And I'm so instinctively used to hitting enter, and enter does something different in Visual Studios. Just kind of messes with your head. Why these ACLA keys aren't being used? They're being passed in. Parameter section is never used. But you are used. I guess it's IntelliJ just being weird again. Okay, so, oh, it's because it's looping, that's why. So we just want to pass in the current enabled status in here. And you know what, actually we're going to do the reverse here. So we're going to move this to here. And we're going to get rid of that. And we're going to call it in the other direction. The reason for this is that it helps with code flow a little better. And then we want to go enabled, or this dot enabled equals enable. Okay. So this improves with code flow because then we don't have to handle enabling on the default. So there's no changing of the enable status. Instead, you're only handling it where you need it. There's like two ways to do overloads. Most of the time, I prefer to do overloads from least arguments to most arguments. So if you have a system that has less arguments, then you want to pass it to the one with more arguments. The other way to do it is taking most arguments to least, but it all depends on how you want to handle it. In this case, going from most to least is more efficient because then we're not handling extra data that we don't need to handle. In assignment type things, like if you were creating an entity that then depended on data, sometimes going from least to most is more preferable because you may be required to set data variables, especially if you have final data. Final data that is being set has to go from least to most because you have to set those finals. If you don't set them, then the class won't compile. But less of a Java lesson here. This all looks good. I don't think I have to mess with that again. So I just need to sync that, which means I need to change the version number. And I've changed this like a couple times today. And then I need to find the build system. We actually transitioned to the new build system, so the old build system is gone now. Or at least I removed it from my workspace, it's still in the remote. So the old build system has been archived. Let me go throw this archive in my folder. Started making sure we're archiving everything at this point. Okay. Of course, I probably need to make an archive folder in here where we just put everything. But I put everything in here. Like I put copies of client projects in here for... Actually, I believe these are not the client's project. I believe these are pre-client project, like before he did anything to them. Because his launcher is based on another launcher. And then, of course, we got the abstraction layer, which we scrapped, but I kept the code because it's a good idea to keep the code. A Pac-Man game I made for a job interview. Weirdest job interview ever was for a hospital. They asked me to make a Pac-Man game. Of course, I didn't get that job, of course, but still the weirdest interview I've had. But I need to go find the build system. So it's called, oh, there it is, Voltage Build. Probably should have submodulated this into the VE thing so I could just deal with it there. It still has the same stuff in it. It still has a source folder. So it still has all of the things in here. So what we want to do is the Gradle properties. And we want to set this to 4. And I need to see if the build server has actually finished running. So if we pull this over here, com, BuiltBroken, coding lib. Okay, so it's a build 3. We want 4, so the next build is going to be 44. The only reason we do this is because the dependency system I coded is not exactly intelligent. I need to go through and I need to update it. It's supposed to support Maven functionality, but it screws up on build numbers sometimes. And it doesn't understand how to find the latest version yet, and that's the reason I have to go back and fix it, because the latest version you could pull from here, and this would be the latest version, and this is what we want to actually check against. We want to go, okay, do we have a newer version, and do we really care if we want to download a new version? Actually, I think that's the reason it fails, is because it goes, okay, we don't care to download a newer version, but I probably need to tell it to download newer builds as long as these numbers match. So as long as it was 2.4, but the build was like, say, 50 or 60, we want to do that, because build numbers would make a notation that we've made fixes, because that's how we use build numbers for all the BBM stuff. The first one is your major, minor, revise, and we treat major as complete overhauls, minor as minor overhauls or changes, revise as in additions or things that are easily backwards compatible. So if we add a new subsystem to this, or we add new classes to this, then we don't need to care about it breaking older stuff, because it's not a major issue. But then we treat build numbers as we've bug fixed things. Only time I will change a revise for a bug fix is if it was a pretty major issue that needed to be noted and that dependencies have to be updated for. But if we don't have to update dependencies, then build number is what we want to check. Updated this. And then, of course, the voltage number hasn't changed any. Actually, we're going to update revise, because we have changed the coding lib We've changed the coding lib, which is one of our dependencies, so we're not backwards compatible anymore. And we're changing the processor system, so we're not exactly backwards compatible anymore, so we have to go up a version. And then I just need to sync that. So this needs to be, oh, you know what, the next version has a build, I didn't upload it yet. Yeah, we just added enabling status. Okay, and that will build, and then I don't think voltage and build server job is actually enabled yet, so pushing this isn't going to do anything. And of course this will be updated coding lib. And that's pretty much been the last few commits for this repository, is all I've been doing is updating coding lib. The cool thing is Voltage finally hit version 1. Although I probably should have waited until I was done with the overhaul before I set it to version 1. But oh well. I don't really care. The version numbers are superficial, they're not really useful. But yeah, updating coding lib. Yeah, and fix mod flags. Yeah, so dmod I think still has a little bit to do on here. He told me it was fixed, but then he told me again like several hours later it's not working properly. We're going to ignore that, and we're going to focus on functionality stuff, because the build server, even though it's broken, it doesn't really reflect on the code itself. That's a completely separate issue that would be dealt with later. So we want to do in here, we want to go engine.running instead. So we definitely want to make sure that this debug stuff for the internal processor is disabled when we're not running as dev, because this is just so much junk data is going to be popped out in this, because we're going to note what data we've loaded, we're going to note subtypes, we're going to note injection keys running, we're going to note subprocessors running. There's going to be a ton of data printed out, and all this data is being used for is so I can double check to make sure the processors did run the way they're supposed to run. We're going to go to work on the injection system. So this system is pretty straightforward. I need to check what type this is. So we're going to go if value is instance of JSON element, because this is going to be what's actually passed in by the processor is JSON element. But we're going to recursively call ourselves. So we then want to go, yeah, so that's how we're going to do our handling. I want to go if value is instance of JSON primitive. Because the thing is, I want to manually handle primitives. So if it's a primitive, I want to handle it. If it's a JSON element, I want to check to see if the target field can handle it. Yeah. That'll be the way we'll do it. So we'll handle primitives by default. And I'm trying to think of how to exactly detect it. Hopefully there's some methods in there. Yeah, okay, so there is Boolean, number. Okay. I have a feeling I've written code for this before. So if value is Boolean, so we're going to do the Boolean there. So we're going to go then if value dot is number, and then string is the last one. Else if value dot is, yeah, I think there's only 3 types you can actually do. The rest of it is, when you hit a number, you've pretty much just got to cast it to whatever you want it to be. So you got parsing for doubles, you got parsing for big integer, or big decimal, which we are not going to support. So if somebody decides to do these 2, I don't care, because nothing in my code is ever going to use those. They're just way too big. The only thing I actually have that actually uses those is a profiling system that has to use them because the numbers are too big. We'll support everything else though. So we'll get shorts, get longs, get floats. Oh wait, there's a character support? Okay, so character supports are getString.char at. And then, okay, we got byte. Okay, we should be good then. You know what? I can't recursively handle these. I'm actually going to have to handle these in place. See, we want to go... Actually, you know what? In the very top of here, we want to go if injection fields dot contains key, and then we want to go key, and then of course we actually want to do this too. String. So we're going to do key value, and then we're going to go string key equals key value to lowercase. Actually, is it already sent to lowercase? Oh, well, whatever. We'll deal with that later. The reason we're doing it this way is I want to register all the keys lowercase and I want to read all the keys in as lowercase. Even if they're not lowercase, even if there's something really janky like somebody's messed with every single other character, it'll force it to lowercase. That way we can more easily confirm what we have. So in other words, our stuff isn't case sensitive. And then in this one we want to do injection methods contains key and then key. So we've got 2 handling systems. Fields are surprisingly not actually used yet, so I don't know why I coded them first. I think it's just because they were the easiest ones to do, but the methods are the ones that we're actually going to care about. But we're going to do both of them, and we're going to write some JUnit code here in a second. So if you can give me a moment to find my test package. And do I have JSON? Yes, I do have JSON. So we want to make a new package called loader. And then in here we want to go test processor injection. And then here we want to make a class injection test. I guess we can just do it that way. So what we're going to do in here is we're going to go, okay, public string key, and then we're going to do a method here. So we're going to go public void key method, and this will be string key. And then we'll put our things up here. So this will be JSON processing data, and we'll call this one key, and we'll call this one key too. And we're going to recycle key, so we're going to do this dot key equals key. So we're going to recycle that variable to use it for both test objects. But this will be just a quick test thing. So we're going to note it test object for at link test processor injection. Okay, we're at 24 minutes recording. Let's see. Try to make sure these videos are always an hour long. I don't think we need abstract test in this case. So we're just going to need to extend test case then. That gives us the framework to call asserts and stuff. Like there's a ton of like assert methods in here, assert false. Then we want to just make some tests. We want to do public void test filled. Oh, come on, IntelliJ, don't break on me. There you go. and then just put a test on top. By the way, when you do JUnit testing, if you're using 3, you can do this. If you're doing 4, it's preferable to do this way, but it'll also read 3. And then if you're using my test system, it'll do both. So I've got my own test framework, which extends the JUnit test framework. It's slightly different in how it handles things. So JUnit 3 and 4 will run each of these methods individually, so it'll create like a brand new everything for both these methods. My Volts engine loader will not. It will create one handling system for the entire class. It will then load up data for the entire class, and it does not isolate methods. So if you ever use my system, make sure you clean up after yourself or you're going to mess your tests up. I've actually seen this happen already a couple times with my systems. The plan is to eventually migrate back to how JUnit 3 and 4 run with the ability to still use the old system. Because the old system has its benefits, like if I want to test a single tile, I don't want to recreate that tile for every single test. I want to create it once and then only use it once. But ignoring all that, so we're going to need to create, actually we're going to want to test init as well. So test init. So in test init, we just want to load up the class and make sure it runs. So injection, or actually JSON processor injection map equals new JSON processor injection map, and then we want to do test, or we want to do injection test class dot class, and this will initialize things. And then what we want to do, we're going to make these public. It's not advisable to do that, but I'm not working in a hostile situation where I need to protect my data. Plus, making things private doesn't actually protect them. It just prevents people from being stupid. But then we're going to, with this, we're going to assert true map dot injection fields dot contains key. So we want to make sure we've detected key. And then we want to make sure that we've detected a method. So we will go with both of these. So it just ensures that when we load up, it does work. It handles our system properly. We can also add another assert after this. We can assert not null. By the way, how asserts work is you're basically going, I want you to test this system and make sure it returns the correct result. It's nothing fancy. To be honest, the thing with JUnit is people kind of go like, oh, this system's amazing. You can replicate JUnit with minimum effort. It's really easy to build your own system that does exactly what JUnit does. The only reason I haven't done it myself is because I like the fact that JUnit works, and then I like the fact that it works with Gradle and everything else. So from Gradle, I can go, okay, run my JUnit test, and it does everything for me. If you develop your own system, you're going to have to come up with your own way to handle all that, and that's a lot of work. So for each of these, we're going to have to recreate this because I'm not using my test system, and I don't really want to. Because if I can use base JUnit for testing, it's more preferable because it runs better. So in this, we want to check to make sure that it can handle a field, just period. So we want to inject a key, and we want to inject a key with a string. Yeah, not fancy. And then we're going to do the same thing down here. Except in this case, we're going to inject key 2 with a string. Then we're going to check you know what? I failed to do something here. Yeah, we're going to need an object there for that to work. I didn't think about that. You can't inject something on nothing, so we need to make an object. In this case, we're going to make a new injection test class. Object equals new injection test class. And we're going to pass this in. By default, because we don't specify this as of a type object, it's going to allow everything to pass through. And in reality, when you compile it, that's actually how it works. The only reason you're going to want to do something like this is it'll cast automatically for you. It'll do various things for you automatically and just make your code run a little more efficient. I try to put some generics in when I can. I do avoid them as much as possible because if you can get away from using a generics, try to do that. They're not the most reliable and they can mess your code up pretty good if you're not careful. I had huge issues with Universal Electricity and some of its sub-projects because CalClav and a few other devs became religious about generics. They make your code reusable, and they really do if you know what you're doing, but if you don't know what you're doing, which is the case of CalClavia, they do mess up royally. We had a lot of issues where we were like, hey, let's make this iConnector class that has generics in it. And then all you have to do is pass in the generic you want, and it'll go, hey, yeah, you can accept this connection. The problem is trying to check what your type was when you had to return a generic of the same type was really difficult, especially in Scala. It made our code go from looking half decent to being really messy and liable to break every few versions. But yeah, we got this. So then we want to just go assert. Actually, we want to do assert true on here too. So because this will return true if it handles, and it will return false if it doesn't handle. So we want to make sure it did handle it. And then what we also want to do is we want to assert true that object.key. Actually, we want to assert equals is what we want to do. So assert equals, and then we want to pass string in. You don't want to do assert same, by the way, because that is going to actually check if the two are the same, and strings are rarely the same. This will work. So this will check everything. This will ensure that everything did work as intended. We're going to have to add JSON handling to this, so there's going to have to be a little bit more work. But this will get our basics out of the way. And this needs to be block property data. Like I'm going to have to make a JUnit test for this whole class. Because this class, even though there is a JUnit tester for it that does test the bare essentials, I need to make one that comes through here and make sure that every single piece of it works. Like all the sub-block processors work, all the recipe systems work, because right now we're not confirming that. Oh, what you want, Tez? Dog's being needy. What? No memento why I go deal with my dog. So I made the mistake here a few days ago of starting to feed my dog in the morning when I got up. She now expects every single day to be fed in the morning. And because she picked up some bad habits from her sibling, she will now whine until she gets what she wants. But not too big of a problem. So back to testing the system, because we got to test all this, that all this works, all these different keys, all the different JSON loading. So we got our JUnit test. And if we run this, this will fail, so I can actually show that. So run test. Oh, it failed on everything. So test init. Assert true contains key. Cool. This is not at all what I wanted. Okay, so debug. What's dumb is I know this system works. So I know this get all fields works, but if for some reason it just failed there. We're gonna hit play again. And luckily there's a second test that'll run directly after it, so we can go watch what it's doing. Oh. Wait, what? Oh, okay, current class, and then we'll get superclass. This system is flawed. Okay. Okay, I see what's wrong with this. This needs to be put down here, because we're not getting our fields on our current class, which is what we actually want. And I'm curious what actually uses this code, because probably there was something once upon a time that used it, and I stopped using it because it didn't work, and I didn't understand why. Oh yeah, there's quite a few. I probably originally developed it just for this too. Some helper classes, reflection utilities. This could explain why RF support almost always fails to load too. Because RF support depends on finding if the RF API is shipped. The irony of it is we ship the RF API now, but it wasn't always that way. This should fix itself though. Okay, stop test. Yeah, we want to run test. Still failing? Yeah, it's still failing. So we want to follow it every stage of the way now. So we're gonna run debug again, and we're gonna work our way through this. And this is the boring stuff I try not to show on this because there is no easy way to do this. Okay, found one field. Did it actually find annotations? No, it didn't find annotations. Why? Why are there no annotations? Because the thing is, this is the whole thing with this is that the annotation system should always return annotations unless the annotations are being stripped somehow. I don't think they are. It's a problem with toying with stuff I don't normally work on, is that it fails pretty easily. So we know this is the problem spot now, so we can remove our debug lines in certain spots so we're not jumping there and then having to jump all the way back. We run debug again. Still not getting annotations. Where's my test object? We are passing in, injection test class. And we have a JSON processor key here. It's not what oh, come on, IntelliJ. It's not what I wanted to type. Port versions. Okay, here we go, retention. Okay, so this is what I want. Because then I can set the retention policy to runtime, because I think... Yeah, because it's only going to save it in the class behavior, and I want runtimes. Yeah, so that's what I forgot to do. So reflection policy, and we got to import this. Aw, come on. Can I just type in runtime? Oh, they worked there. So that should fix it. And I say should, but as you've probably noticed from my other videos, should actually means it's going to probably crash again. Nope, we found a key. Cool. So if we open up annotations array, there's our thing. Okay, so we go through here, we iterate, finds it, gets a value, gets the string, puts the key in here. By the way, the reason we loop over keys is you can set multiple values, because you can't put multiple annotations of the same type on a field, but you can put an annotation that contains multiple values. So that's how you deal with that. Anyways, that works. And all of our tests, did they pass or fail? No, they still all failed for some reason. Let's run that again. Why are you guys failing? Ah, want to know why? Because we actually haven't programmed handle light. I think I mentioned this already. It's not implemented. So if we know we're a string here, how we literally do this is we go string equals value dot get a string, and then we want to get a filled. So we want to go if injection fields dot contains key, and of course we get our key. If not, we want our methods. So yeah, because one of these two has got to be true. So if we check true here and it's false on this one, this other one is true, which would be the injection methods. So in here we're going to do filled equals injection fields dot get, and we want the key. Then we're going to go filled dot set accessible true. Actually, we want to do it this way. If filled dot is accessible, then we want to set it as accessible. Trying to think if I want to restore accessibility, and the answer is no, so technically I'm just going to do it this way. Sometimes when I'm making reflection utilities, I will restore the default state of the field after I'm done messing with it, but there's a lot of times I won't because there's no point. A lot of these times you'll see is where we have a field that has the thing final on it, and I don't want that field to be final, so I'll strip the final off of it and just be like, screw your field, it's going to stay as modifiable. Other times, if I'm messing with forge code, for example, I will restore the final to prevent another developer from messing with that field indirectly. And this is not to prevent it as in I don't want them to do it. This is to keep stupid things from happening because developers can write some pretty bad code sometimes. But we're going to go fill.set string. Or in this case, we're just going to do set this because there's no string value. So we want object and we want string. And make sure that is correct. Object, yep, and value. And we're going to try to catch this whole thing. No, actually, we're going to put... How do we want to handle this, actually? Because I could just tell the super method that it's got to deal with it, or the calling method in this case it would have to deal with it. Because I want the program to crash if it fails to access a field, because it needs to do that. Because if you can't set data on something, you're going to break it. But then I need debug, so we're going to put a try catcher on this because I need to tell the user why it's crashing. In this case, we're just going to do this real quick, and then we're going to add catch clauses. Okay, so we want to throw a new runtime exception. Failed to access filled. We put the filled in here. So we actually have some debug information, and of course you want to throw the normal exception in. Oh man, I forgot to charge my headset last night. I don't know if you guys can hear the beeping when the power starts to fail on these headsets, but yeah, I'm using a wireless headset, so this has to be charged, and unfortunately, power failure. You know what? We need a second one here. We're going to put an exception E here. So anything goes wrong, like anything in this entire process goes wrong, we want to know what happened. So if exception E, it'll be unexpected error, setting filled with, and then we want value. Actually, you want string in this case. And we'll pop this up to the accessibility thing. Failed to access filled. No, actually, we don't need the data because it's just straight out we failed to access the filled. We're good there. Now we get to do the method version. The method version is actually completely different, but we'll work on it. we'll work on it here. So we want to get method equals injection methods dot get, and then we want to pass in key. Yeah, we don't have to worry about null point checks here. We do need a try catch though, because we got to do the same exact thing with the try catches. So we want to do method.setAccessible to true. Then we want to go method.invoke. And in this, we need the object and the string. I guess this isn't too different. It's pretty much the same code set. I thought it was going to be a little bit more complicated in my mind because of the fact that when you have to go find a method, you have to do a whole bunch of work to ensure the method is correct, make sure you have the parameter types. We're going to do all the parameter type checks up here, so it'll crash up here if it's all fucked up. Actually, won't really do anything up here. We'll just load the method. We'll assume that the person has constructed their method right. And if it becomes a bad enough issue where people aren't constructing their methods right, then I'll put handling up there. Not before it's a waste of time. But we're going to do pretty much the same thing here. So we're going to go failed to invoke method. Then we're going to go method with data, and then we're going to pass in string. And then we're going to copy this again because this is actually what we want. So failed to access, and we're just going to do method. And then we'll do our global version down here. The irony right now is my phone just came on and told me it's charged, so the phone's charged. I remember to charge the phone, but I do not remember to charge the headset. If you actually ever ask my buddies, this is pretty normal for me. Yeah, we actually want this. Copy this whole thing. Unexpected error, invoking, and then we'll pass a method. Okay, so that gives us all of our proper error handling. I have a feeling I can make this code reusable. You know, the only thing that's going to be difficult is this part right here because this is ambiguous because I don't know exactly what the type of number is without doing a lot of work. There's a way to get it to work, but it's going to be a pain. We're just going to do this the hard way, and I'll figure out a reusable way to do it later. So we know this is a Boolean, so this is going to be, we're going to rename this to Boolean. Cancel. I actually have to change it to something else. We're going to call it bool. And this will be type Boolean. And then we just got to go get Boolean. So then in this one, we're going to set Boolean because that's an actual thing. And I actually want to see what this does. Illegal access, okay. Reflection, quick check member access, get field access, set Boolean. And of course, this is a native method thing, so I'm not going to see what that is. I was hoping I would get to see what that is, but not going to get to do that. Should work, because if invoke is the same, this is the reason why I was like, yeah, I wonder if I can make this reusable. Because of the fact that this code doesn't really change much. The only thing I gotta change is like the set booleans and stuff, just to make sure I'm doing the absolute most I can to try to call the right methods here. But the method invokes, they're always the same. You're passing in data. The data is always pretty much the same. It's always just going to be an array of stuff. The only downside is if I had to go search for the method, but I don't have to search for the method because I'm going to get a list of methods up here, and I'm just going to make sure that the method has a parameter. That's literally the only check I'm going to do. Cool. I'm going to copy this real quick. I just forgot what I was doing, and I need to actually be doing this. So we need to go if value is instance of string, and then we pass in value here. The reason we're going to do it this way is because those unit tests will not function properly. Okay, so that'll do our string, and then how we do this is we're just going to recursively call. So we're going to return handle, object, string, or no, we want to go key, and then string. And we're going to do that for the numbers too. So we're gonna figure out what these numbers are, and then we're going to handle each one of those individually. So there is a way to do this. I think there's a way to do this. And this may come down to you know what? We're going to Google this real quick. So JSON primitive. So we're going to go JSON primitive types. Okay, it's not what I need. JSON identify. So basically what I'm trying to figure out is how can we tell what type of number we are? Because we can't parse as a string, because what we're getting is not a string. It is definitely a number. So we got to figure out primitive numbers. So here's, we know number. Okay, it's not what I need. So I hate when I go through Stack Overflow and it's like, oh, go use this library. It's like, there's so many libraries. I'm committed to JSON at this point. I can't go use another one. You know what? We're just going to parse as a double, and because everything converts to a double, and then we'll just have to figure out what we need, and we'll cast down as needed. Java won't cast down automatically for us. It's only features like C have and stuff. Or actually, I think C++ has that. It's auto promotion and demotion. Java only has auto promotion. So we need to parse as a double. So in this case, we're going to go get double. I got a better idea. If we can get the type of the data input, then we can do that way. So what we need to do, and I'm just going to, rather than just doing fancy parsing for this, we're going to modify our annotation. So we're going to go string type default unknown. So this gives us a type variable to use. And with this, we can insist that the type is something. All I gotta do is document these two while I'm at it. List of keys to use. And then we want here type of So we'll do that, and what that lets us do is get the type, and then we just need to store the type here. So we'll need an extra map here. So we're going to go with this, and because there only should be one key handler for each string key, all we have to do is do another string map. And this will be injection types. So we'll use the secondary key, and what we'll do in here somewhere is right when we're putting the key into the field, right below it, if annotation.type does not equal null, and annotation.type you know what, I forgot to do key to lowercase. You know what, we have to do this actually here, because this has to be stored per key. So this would be key to lowercase, this would be key to lowercase. And then what we want to store is annotation.type. And of course we want to lowercase that as well. Let's see, what do we got here? Yeah, that looks good. The only thing I'm actually missing here, and actually I'm going to go key value here so I can save myself a little bit of time. I'm going to go string key equals key value to lowercase. And then we want to change this up to put this here. And we're going to go key value doesn't equal null. Put that there. That'll prevent us from having to lowercase the key every single time. Although in reality, that's only like 2 instances, but oh well. Saving performance, saving performance. It helps a little bit. Okay, so we got that. We got putting that there. Got an error down there somewhere. Yeah, the thing I was forgetting to do is I need to go if injection fills.contains key, we want to throw an exception. Let's see. Duplicate fill or duplicate key detected for that's probably not going to give much data because I don't think a field prints out what class it belongs to. Actually, you know what? This is all single layer class based. So the only thing you had to worry about here is if you have a duplicate field key on another field, because we don't store multiple fields. It's one field per key, not 15 fields per key. But what are we doing down here again? So if we're number, what we want to do is get our filled things. So it's literally the only place type is going to be used. So we're going to do this, and we're going to put it here. And we want to figure out what our number is. It's only the method actually, the one that actually needed this. The field we can double check. Yeah, so I think we can do it. So field dot, there's a get type. So we want to go, yeah, that's pretty stupid about having to do this way though. Class type equals this, and I swear I've done this before. I'm trying to think of like where I've done it, but if type is instance of integer, then what we want to do, okay, is that not how that works? Can't cast a type. Generic type. What are you? Returns a code object that represents the declared for the field by this field. If the is a parameter type, object return must be accurately reflected the actual type parameter used by the source code. If the type of underlying field is a type variable or parameter type, it is created, otherwise it is resolved. Returns a code type object, generic signature error format if the generic field signature does not conform with the whatever. That's what we need though. So get what was it? I should have paid attention to that. So we want the one that returns the type object. And I'm just going to copy this real quick because when you copy and paste it, it recognizes where the source came from. There we go. The thing is, I'm not quite sure how to get this. And what are we at recording time here? Wow, we passed the hour mark. Oh well. We'll see how this works. We're getting there though. Just taking a lot longer than expected. You know what, we're just going to ignore this part and we're going to go back to how I was going to do it originally. So we're going to go string type equals injection types dot get and pass in the key, and then if type equals int or type equals integer. And I just did this wrong. So it actually has to be done this way. And I need a null check here. So I need to go if type doesn't equal null. There we go. So we do integers. This will just be fill.set stupid thing is, if I throw this exception, it's going to get caught by this. We're going to remove this actually. 'Cause I don't really care to propagate. Because these are expected errors, and then you have unexpected errors, and then there's a difference between the two, and I'm just going to remove that because it saves some time. So we're going to set int, we got our object, and then we want to value.get as int. And then we just get to repeat this a couple times. So we have byte, and we want to get as byte, and of course we want to set byte, and then we get short. And I might recycle this code here in a bit just to make it easier. What this essentially means though is in order to use this system, somebody's going to have to define what their number type is, which I have a couple of those I'm going to have to fix. because I don't want to write super fancy code to detect what the type is, because I kind of didn't want to write this system in the first place. The only reason I'm doing it is that it's necessary. It's hit the point where the data objects are going to get so large and so complex that I don't want to be sitting writing manual loading for every single one of them. And to be honest, if I could have used the JSON system to load it up, I probably would have. But I looked at it and went like, you know what, this is going to just take too much time to handle. What other types we have? We set float, set double. Int, byte, boolean. They get covers. Oh, the way long is the last one. And I may come back through here later and actually add a little bit more intelligent handling to this, where it goes, oh, you changed your type to a double, but forgot to tell me, but you're still doing, you're pulling in a float. I'll auto promote for you, so it still works. But that'll be another day type of thing. So that handles all that. So we've got our boolean, we've got our string. We were about to do the else statement here before I got distracted. Or no, this is the method setup. So for this, I got to do the same exact thing. Forgot to grab the type key. Gonna replace the field there. Got to get rid of this. This will be a method, and then this needs to be value. And what we want to do is replace every single one of these with method.evoke or invoke. And we can do this really quickly by doing this. And that's not actually, I needed it to, I do not remember enough regex to use regex. We're gonna try though. Come on, you can do it. That got me the whole string. Do not want the whole string. I don't want to match the whole thing there. You're trying to match the last instance of. I don't want the last instance of. Why does regex never want to work just precisely? We'll replace the first half and just delete the rest manually. Completely defeating the point of trying to use regex. Only problem is matching the last, and my understanding of regex is really low, and I've only recently learned enough to actually start using it again. Every other time I've had to go find some kind of system that would pretty much do the regex for me. But a lot of our stuff's using regex now. I want to move as much as possible to regex. I plan to do my command systems with regex, because with regex you can make commands that aren't required to be written in a certain order. So instead of going like set region, I can do region set, and they would both validate to the same command. Technically, although that's not exactly a best case there. So we're going to handle strings outside of this. I then need to do numbers outside of this. Numbers have to be handled differently if they're an actual number, because we want to try to go to the type as best as possible. Well, this is where the auto converting would come into play, is where if we loaded in a float and we want our number to be loaded as a float, of course. So if they say, hey, I want to load as a float, but then my parameter is a double, or if it's in or something, we auto cast. We'll do the same thing here. But for the moment, I'm not going to worry about. So, oh, what is this? We are in the wrong spot with that method. Okay. And this needs to return true. I forgot we're not returning true to say we've handled things. So that's return true. Then we're just going to return true at the bottom of this. I'm not going to deal with this whole thing. There'll be an else statement to say like unknown type, I guess. We'll go throw unknown number type with at the bottom of both these. Because you want this to throw exceptions when it's failing to function properly, because who knows what that data could be. That data could be incredibly important, or it could be not important at all, but either way, a developer is fucked up at some point, and the developer needs to be informed that the program does not run. So we're going to just finish some of this off, test this, and close the video out pretty soon. I probably could have wrote all this JSON stuff another time and just did the bare minimum here, but I got distracted, and I apologize. So let's see. In this case, we are just doing value. And that's about, yeah, so this works out surprisingly. Anything that's an object that gets passed in. Okay, so where is our handling? So we go all the way down here. We want to handle objects, and we'll just be like, hey, if we contain a key for you, just handle it automatically. Yeah, that'll work. That'll handle pretty much everything we can throw at it. So if I run this system, it should work again. And it's not working, which just proved me wrong there. It didn't. We're not loading the methods. That's why that isn't working. This, I think, did run. Because the other thing failure is a method system. So now we just got to do method loading. Mute my mic there for a second while I chewed on some M&Ms. Okay, so now we want to get all the methods. And we're going to have to do this. Basically rewrite this because I can't go copy the filled section like I was thinking about doing there for a second. We'll have to check to see if this has that same exact issue the other one has. Class not found exception. This doesn't throw a class not found exception. It self-handles. We'll apparently it doesn't need that. But well, here's the one I want. Let's get all methods. So this does annotations. Okay, so we got get methods and we got, okay, I see what going on here. Probably didn't need to edit any of that stuff, but I edited it anyways, and I don't really care. So what we want to do is we want to go for methods. And we want to get the annotations. So okay, and to be honest, we actually can copy. Yeah, we actually can copy this whole thing. I don't know why I was thinking I couldn't do it earlier. We just got to go through and change this stuff. The only thing we do need to do on this is ignore any methods that don't have parameters. Or rather, crash if we don't have parameters. So we want to go if method dot get parameter count does not equal 1, then we want to throw an exception. Probably like an intelligent way to do this where I could actually make the compiler give this warning too. But I think I need an annotation. Actually, yeah, annotation processor would fix that, but I'm not going to code one right now. This should work. It does not. Oh. Not sure why that would be null to start with, because it validates. Oh no, I understand what that I did there. Okay, all 3 tests passed. It shows the system is working. I'm going to cut the video here, take a break, get some food, and then come back.